Welcome back. Welcome to this video on Learning Path 05 Java AWS Expert. A number of times we are asked a question, how can I become a microservices developer? How can I become a cloud developer? How can I become an AWS expert? How can I become a cloud expert? And these learning paths are a solution to that question. Each of these learning paths will have a prerequisite, it will have a goal, it will have the tool and framework recommendations, it will have the learning path recommendations, as well as it will have recommendations on what videos to watch and what courses to pursue to achieve the goal. In this learning path 05, we would want you to be an AWS expert. We would want to take your Java Spring Boot applications and deploy them to AWS and make use of the different services which are provided by AWS. AWS provides a number of application related services. AWS Elastic Beanstalk is a platform as a service offering of AWS. AWS ECS Fargate is a container orchestration service provided by AWS. Docker is a tool to build images for your applications. Kubernetes also is a cloud neutral container orchestration tool, and AWS EKS is a service provided by AWS for Kubernetes. Does all this jargon sound very complex? Don't worry about it. Let's deep dive now and let's make all this stuff very simple for you to understand. Before we go any further, the most important thing is the prerequisite for this particular learning path is that you should have completed either learning path 01 or learning path 02. You'll find links to these learning paths in the description of the video. So these learning paths would help you a web application or a REST API or a full stack application with Spring, Spring Boot, JPA or Hibernate. So once you have that expertise, we can get into the cloud. Let's get started now. Now, let's shift our attention to one of the most important topics of the recent years, cloud. Why should you learn the cloud? That's the number one question. And what should you learn about the cloud? So let's get started with the first question. Why learn cloud? The number one reason why you should learn the cloud is because of something called on-demand resource provisioning. What is on-demand resource provisioning? In the cloud, you can get resources whenever you want to ask them for. If you look at the world before the cloud, you have to start planning infrastructure months ahead. So if I expect a huge amount of load, I would need to start planning the infrastructure well in advance. However, with the cloud, you don't really need to do that. You can ask for a resource when you need it and you can release it when you don't need it. What are the advantages of that? Let's say you are Amazon. You'll have peak period of load during any of these shopping seasons. Let's say Black Friday. Let's say a New Year's sale or something of that kind. For rest of the time, you will not have as much load. What would the infrastructure be doing when there is no load? It would be sitting idle. That's what you can avoid by going to the cloud. Let's say you are a startup. You don't know how successful you will be. So you can start with a little bit of resources in the cloud, and as you grow, you can increase the number of resources that you provision. So on-demand resource provisioning is one of the most important reasons why cloud is becoming very popular. Now, what are the other reasons? The other reasons are avoid undifferentiated. So this is a little tricky. Undifferentiated heavy lifting. What is undifferentiated heavy lifting, right? So let's say you are an insurance business. What would differentiate you from your competitors? It's about giving good insurance products. Let's say you are a shopping platform, or let's say you are a bank. What really separates you from your competitors is not the technology platform, it's not how you do service discovery, it's not how you build your containers, it's how you service your customers. So that's the important thing for a business to focus on. How to do containerization, how to do service registry, all that stuff is actually part of something called undifferentiated heavy lifting. It's a lot of hard work that you do without a huge amount of differentiation from your competitors. And businesses should avoid undifferentiated heavy lifting. Cloud provides a number of services like managed databases, like platform as a service offerings, where you don't really need to worry about how the platform is working. All that you need to do is build an application, deploy to the platform, and the platform would make sure that the availability concerns, the backup concerns, the redundancy concerns, all of them are taken care of. So, number two reason why people go to the cloud is to avoid undifferentiated heavy lifting. You don't need to do the stuff which does not give you any differentiation. The third reason why people go to the cloud is improved latency and availability. So, what is improved latency and availability? With the cloud, you get a feature which is called availability zones and regions. So, if let's say this is the world map and you have a number of continents everywhere, I'm not really good at drawing maps, so that's something you have to forgive me for. Each of these cloud providers, whether we are talking about AWS or GCP or let's say Azure, each of these cloud providers have regions across the world. So they have regions in all the important continents across the world. So they have data centers present in different corners of the world, and even within these regions you have things called zones or availability zones, where you have multiple instances present. What this helps us to do is, if you are a startup, you don't really need to have all your data center at one place. What would happen if I have data center at one place? If a request comes from a customer in somewhere other corner of the world, then the request for him will be slow. So there will be latency for that specific user. And you can avoid that by going for the cloud. You can deploy your application in multiple regions with a single click of the button, and therefore your users will get the best latency, best performance possible. You can also improve the availability of your application. So inside the same region, you can deploy it into multiple availability zones, so that even if one of the places the application goes down, it can be served from other places. So that's the reason why cloud is really getting popular in these days. So now you have decided you want to move to the cloud. You are satisfied with all the reasons. The first decision that you need to make is, how do you move to the cloud? And there are a number of options on how you can actually move to the cloud. The first option is something called lift and shift. Let's talk about it a little later. For now, let's list down all the options. The other option, the second option, is to actually use a cloud specific application platform as a service. So this lift and shift is called IaaS, where it's called infrastructure as a service. The cloud specific app, PaaS, is platform as a service. The other options are cloud specific, container orchestration. So container orchestration. The fourth option is actually cloud neutral. So instead of specific, this is neutral. So cloud neutral container orchestration, typically using Kubernetes. The last option is also very interesting. You have an intermediate platform. Instead of going to the cloud directly, you can go through an intermediate platform called PCF or OpenShift, things like that. So these are all the options that you have to go to the cloud. So let's start with actually discussing what is IaaS versus PaaS, infrastructure as a service versus platform as a service. Typically, whenever we talk about applications, where do they run? They run on hardware, right? So you have networking. So you have networking, you have hardware. On top of the hardware, there is also storage and other stuff which can be present, hard disk and other stuff. On top of it, if we are in the cloud, we would need to have some kind of virtualization so that we can use the hardware in the cloud. On top of it, you would want to install the operating system. On top of it is where you would have your runtime. So the runtime can be application runtime, container runtime, or whatever it can be. And on top of it is where our apps run. So finally your apps, your data, everything is at this particular layer, right? So this is how things are in the cloud. So you have your network connectivity, on top of it is your hardware, you have virtualization layer, you can install whatever operating system you'd want, you can actually choose any runtime, maybe you'd want to install Java, you would want to install Tomcat, all that are runtimes, and on top of it is your apps. So that's the whole thing. Now, from the cloud, you can ask for just the servers. So you can actually ask, hey, I would want a Windows operating system and I would want one virtual server. That's called a infrastructure as a service. So you are asking a server, you are asking a specific service with a specific operating system. Typically, all these cloud providers provide infrastructure as a service as well. So in Google Cloud, these virtual servers, so whatever virtual servers we are talking about in here, let's just say virtual servers. In Google Cloud, it's called as compute engines. In Microsoft Azure, it is called as virtual machines, Azure virtual machines. In AWS, these virtual servers are called as EC2, Elastic Compute Cloud. So the names are different, but the concept is same. You can say, I would want a virtual server with this configuration and this operating system. And then you can take that and you can install whatever runtime you would want. You can install Java, you can install Tomcat, you can install whatever you'd want, and you can install your apps and databases on top of it. So this is what is called infrastructure as a service. You can go for this. So you can take your application which is present outside, right now in your data center. You can take it, you can ask servers in the cloud and you can deploy it as it is. So let's say you have an application which is running inside your data center. Let's say it's like Tomcat based, running on Unix. You can ask for a Unix server and then you can install the Java and you can install apps on top of it. So you are taking complete responsibility for this specific part. So the platform provides all this stuff and you are responsible for runtime and the apps. The other service which the cloud platforms also provide is something called a platform as a service. It takes it to the next level. This is called a platform as a service, where they provide the runtime and they provide a number of additional features as well. They take care of availability, they take care of taking backups, redundancy, and all that stuff the cloud platforms can take care of. Let's look at a couple of examples of PaaS. So let's start with, let's say I would want to deploy an application. What are the platform as service offerings that are present that can help me to deploy a Spring Boot application to the cloud? Let's talk about AWS. With AWS, the platform as a service offering is called Elastic Beanstalk. AWS Elastic Beanstalk. The awesome thing about Elastic Beanstalk is you can give it a var file or a jar file and that's it. It would take care of managing it. If you want multiple instances, it can create it. If you want load balancing, if you want auto scaling, all that stuff are built in. So you are only worried about the apps. The rest of the stuff, the platform, AWS would take care of it. Similar services are also provided by other cloud platforms. Azure provides a service called App Service or Web Apps. So Azure Web Apps is an amazing service. Again, all that you need to do is give it a jar, a var, a container, any of these things. All these services work with all that stuff. So it would be able to manage the whole thing. So the Azure Web Apps is a platform as a service. And Google also provides something very, very similar. It's called Compute Engine. So Google Compute Engine will help you to manage an application. So you give it a jar or a var or a container and it would take care of rest of the things for you. Now that's one way, deploying applications. The other way you can make use of PaaS, platform as a service, is by using something like databases. So you can use the database services which are provided by the cloud. In AWS, you have relational database service. In MySQL, you have a MS SQL database service. Similar services exist in Google as well. So instead of managing the database on your own, taking backups, managing the availability, making sure that the redundancy is present. By redundancy, I mean instead of having the database present in one availability zone, one place, you can have it present in 2 or 3 availability zones which in the same region, so that even if one of the availability zone goes down, the data from the other availability zones is present for you. So all this stuff are automatically provided by the platform for you. All that you need to worry about in the case of databases is the data. You don't need to worry about how to install a database and all that stuff. All that stuff would be taken care of by the platform provider. So the first option we looked at was infrastructure as a service, where the cloud provider would provide you just the infrastructure and you do the lifting and shifting. You take care of installing the applications, installing the runtime and all that stuff. The second option we looked at was platform as a service, the basic platform as a service offerings, right? So databases, in the case of like each of the clouds, there are basic platform as service application offerings. The other option you have is, let's say you are having microservices. In those kind of situations, you'd want to go for container orchestration. If you have multiple microservices and they talk to each other, you'd want to manage them using something called a container orchestration tool. So you can go for a cloud specific container orchestration tool. In AWS, there is something called ECS or AWS Fargate. So AWS ECS, you have to manage the clusters. AWS would take care of actually providing, with AWS ECS, you are responsible for providing the container images, configuration, and you are responsible for managing the clusters. With Fargate, you are no longer responsible for managing the clusters. You are just responsible for managing the applications, the container images, and the configuration. Fargate would automate everything. Fargate is also called serverless for containers. So that's the option number 3. So this is option number 2, 1. And the fourth option is actually to use a cloud neutral container orchestration. The problem with the cloud specific container orchestration is if you are using AWS Fargate or AWS ECS, then you are tied to that specific cloud provider. You can go for cloud neutral container orchestration by using Kubernetes. So you can create containers, you can create containers for your microservices and or get them orchestrated by Kubernetes, and each of these cloud providers provide Kubernetes services. Google provides GKE, Google Kubernetes Engine, Azure provides Azure Kubernetes Service, AWS provides Elastic Container Service for Kubernetes, EKS. So all these are like the Kubernetes offerings from various cloud providers, and once you use Kubernetes, the advantage that you have is even though you are running on the cloud, you can shift from one cloud to another without a big problem. The other option is to use an intermediate platform. Option number 5 is to use an intermediate platform like PCF. If you are a Java shop, if you are using Spring Boot, if you are using Spring Cloud, then PCF might be a very interesting option. So what PCF does is it sits in between your apps. So you have PCF in here, you have your apps in here, and below this is your cloud. So it might be AWS or it might be Azure or it might be Google Cloud. So you can deploy your apps to PCF and PCF would take care of using deploying it to the right cloud. So you can configure how you would want to do it and all that stuff. So with PCF, it provides a lot of interesting features which makes it very, very interesting, especially if you are a Java shop. If you are doing a lot of Java things, then PCF is a very, very interesting thing. The idea behind giving an overview of the cloud is to show all the various things that you can learn about the cloud. As far as this learning path is concerned, we'll probably focus on just a few elements of this cloud learning path. We might not want to learn everything because that would be tough. So we would focus on specific things as part of this learning path. Now, we talked about a number of platform as a service offerings. We talked about Elastic Beanstalk. We talked about App Engine. We talked about Azure Web Apps. And we also talked about PCF. If you look at all these platform as a service offerings, they offer a few common features. One is you can have any number of applications deployed. The other is they all support multiple environments. So you can have a dev environment, a QA environment, stage environment, and all that stuff for all the applications. They have different names for each one of these, but basically they support multiple environments. You have support for multiple platforms and also multiple languages. So you can deploy a Java application, a Python application, and all that stuff. You can deploy a jar file, a var file. You will also have support for container and a multi-container application. So you can build an Docker image. You can use that to deploy an application down to the platform as a service provider, and you can also use a multi-container. So if you are aware of what Docker Compose is, you can run multiple containers at the same time. So you can use that stuff also to run your applications. So most of the cloud provider platform as a service offerings, Elastic Beanstalk, provide support for multi-containers as well. These platform as a service offerings also allow different deployment strategies. When you want to release a new application out to production, you don't want downtime at all. You want one service, while the service is live, you'd want to be able to test the new version of the service and take the old and replace the old version with the new version. This is called blue-green deployment, and almost all the platform services, platform as a service offerings, the basic ones, support this. The other options that are provided are auto scaling. You can scale the number of instances based on the demand. You have load balancing present. So you can load balance between multiple instances automatically, and they also provide a continuous integration and continuous deployment options. In the case of AWS, you can do actually it's AWS Elastic Beanstalk. So this is AWS Elastic Beanstalk. This is Azure, actually this is Google App Engine. This is Azure Web Apps. Oops, it's a little confusing now. So in the case of AWS, you can use AWS Code Pipeline and Code Build to do the continuous integration and continuous deployment. In the case of Google App Engine, you can use Google Cloud Build. In the case of Azure Web Apps, you can use Azure DevOps to do the continuous integration and continuous deployment. So all that you need to do is you have your code in a Git repository. So once you commit the code out, so from your local machine, you commit the code out to the Git repository. You can have a build scheduled using any of the tools that we have talked about right now, and it would directly deploy it to the appropriate platform. So this is the advantage of continuous integration and continuous deployment. You can continuously keep deploying new versions of the code, and if you have automated tests and all that stuff, that's amazing as well. Now, one of the important questions you might be wondering is how to identify which one to choose, right? It's a very, very difficult question because most of the basic features are provided by almost all the basic platform as a service offerings by all the cloud providers. So let's look at a few of the differentiators. One of the interesting things about Azure Web Apps is that it provides a concept called app service plans. So Azure Web Apps provides a number of app service plans like F1, B1, B3, P1, V1, and a lot of other stuff. These app service plans define what are the capabilities and what are the capacities. What I mean by capabilities is things like, is auto scaling supported? Can there be multiple slots? Can I have multiple environments? Are backups automatically taken? And by capacities, I mean how much CPU, how much memory. So in Azure Web Apps, before I would be able to deploy an application, I would need to create something called an app service plan, defining what are the capabilities I need and what is the capacity I would need. And the interesting thing is the building starts as soon as I create an app service plan. So even though there are no apps, the building starts immediately. So that's one interesting thing about Azure Web Apps. The other interesting thing that might be useful in Azure Web Apps is resource groups. So you can actually group a lot of resources belonging to single application into a single resource group, and it really helps you to manage things very, very easy. And one interesting thing about Azure Web Apps is it has support directly for Docker Compose. So earlier we talked about multi-container support. You can directly take your Docker Compose file and run it directly in Azure Web Apps. However, like in things like Elastic Beanstalk, you had to actually adhere to a AWS specific configuration file. You cannot use Docker Compose file for multi-containers. You have to actually change it a little bit to adhere to a AWS specific multi-container file. The other interesting thing about AWS is the S3. So there is something called S3, which is object storage. So S3 is an object storage in AWS. The interesting thing is S3 is highly available. I mean, we were talking about multiple regions, multiple availability zones and all that stuff. With S3, anything you have in S3 is like really one of the most available things that can be present in our planet. So if you deploy and the interesting thing is actually you can deploy a front-end application to S3. So anything that you would want to actually run in a browser, you can actually deploy it to S3. So JavaScript, HTML and all that kind of stuff you can deploy to S3 and make use of all the features that S3 provides, like availability, latency, like low latency and all that stuff. So S3 is one of the big differentiators with Elastic and going for AWS, because you can actually deploy a front end to S3 and it would take care of all the service requirements that you have. The other interesting thing is the fact that Google App Engine is actually one of the oldest. I don't know if it's really an advantage, but it's really one of the oldest. I think Google App Engine goes as far as 2008. Now, one key differentiator for PCF is it has amazing support for Java, Spring Boot and Spring Cloud. Also, the other important thing is it supports all the microservice infrastructure needs as well. Let's say you'd want to deploy a microservice to PCF. You typically need things like service registry, config server, histories. All these Spring Cloud services are offered as managed services on PCF. So it makes it very easy to deploy your Java, Spring Boot, Spring Cloud microservices out to PCF. So those are some of the important differentiators between all these platform as a service offerings. The best way to learn all these platform as a service offerings is to deploy multiple applications, deploy a jar file, deploy a war file, deploy a REST API, deploy a web application, deploy a full stack application and play around with it. Now let's shift our attention now on how to learn AWS Elastic Beanstalk. What are the things you can do to learn Elastic Beanstalk in depth? One of the key things that we would recommend for any platform as a service offering is to deploy multiple applications. So you can actually deploy a jar file, a var file, you can deploy a REST API, you can deploy a web application, you can deploy a full stack application and try Elastic Beanstalk. So that's number one thing that you can do to learn Elastic Beanstalk. The second thing that you would want to do when you would play with Elastic Beanstalk is to try all the services which are present inside AWS. So you'd want to be able to create a database and connect your Elastic Beanstalk environment to it. So you'd want to maybe use the RDS service. You'd want to play around with continuous integration and continuous delivery with AWS code pipeline and AWS code build. You might want to try different monitoring features that are available like Cloud Watch. So these are all the interesting features that you might want to learn when you are playing with Elastic Beanstalk. Now let's move on to how you can learn Docker. How can you create images, containers and all that fun stuff with Docker? Before we get there, let's get started with the most basic question that we try to answer every time. Why do we need Docker, right? We talked about microservices architecture. In a microservice architecture, what we have a number of microservices, A, B, C, D, E, maybe thousands of them. And these are all talking with each other, right? So that's how microservices architecture works. And one of the flexibilities microservices architecture provides is each of these applications can be in a different language, different platform and stuff, right? So these microservices might be developed in Python. This microservice might be Java. This microservice might be Node.js. So one of the interesting things about microservices is also that you want to automate most of the things. So your deployment should be completely automated. Now, if you have different ways of deploying Python, different ways of deploying Java application, different ways of deploying Node.js, can you automate the deployment? It would be very tough, right? But you cannot prevent innovation by saying, okay, we are only going to use Java. we're going to use Python and all that stuff, right? So that would make it like monolith where you had a lot of restrictions. Now, how do you leave the flexibility and still have automated deployments? That's where a technology called Docker comes into picture. Docker helps you to build a similar image. So whether you have a Python application, whether you have a Java application, whether you have a Node.js application, you can build a Docker image for all these, and you can take the Docker image and run it wherever you would want to run it. So this Docker image would contain two important things. One is your application, and also it would contain your application runtime. So you can say, I would want Java 8, I would want a jar file present in here. Or I can say, I would want Python installed and I would want a Python application in here. So this Docker image contains everything you would need to run your application. So Docker helps in standardizing packaging. So that's number one thing, standardizing packaging. So that's the number one thing that Docker enables. So whether it's a Python application, a Java application, or Node.js application, you deploy it the same way. The second thing that Docker enables is minimum virtualization tax. What is virtualization tax? So let's write this down. Minimum virtualization tax. Now, before Docker, typically what were used were called virtual machines. In virtual machines, what used to happen is there used to be two operating systems, one host operating system, another guest operating system, and due to which the performance was suffering. So if, let's say, if you directly use a server, you would get a performance of X, you only get a percentage of that X when you virtualize it and run your software on top of it, because there are two operating systems running. However, Docker simplifies that. When you are running something in Docker, all that you would have is, let's say you are running Docker on the cloud. So you have your cloud infrastructure. On top of your cloud infrastructure, you would be running your host OS, and on top of it, all that you need to do is install something called a Docker engine. So this Docker engine is what does the magic, and on top of the Docker engine, you can run the containers. So you can run C1, C2, C3, multiple containers. And the interesting thing is you don't really have two versions of the operating system. There is just one operating system, and Docker engine makes sure that it takes care of all the things that your Docker containers would need. So in Docker, there is no virtualization tax. So there is like very minimal impact on the performance that is provided by the infrastructure to the containers which are running. The third important thing is container isolation. Container isolation is very, very important, is because if, let's say, this container fails, the rest of the two do not get affected at all. Or if it wants to get a lot of memory, it wants to take all the memory which is available, you can prevent that from happening. So you can give proper container isolation with Docker. Number four, the fourth reason why Docker is very, very popular is because, as we said earlier, it's language neutral. So it does not matter whether it's Python, Java, Node.js, whatever it is. You can build a Docker container for it. You can build a Docker container for a web application, a full stack application. You can build it for a batch application. Whatever you would want, you'd be able to build a container for it, container image for it. So it's language neutral. The other thing is it's platform neutral, and also it's cloud neutral. You can use Docker containers and deploy them into AWS, Azure. You can deploy it to Google Cloud, wherever you'd want to run. So these are the whys around Docker, right? So this is the reason why Docker is now one of the primary ways of how applications are deployed. So if you are talking about microservices, typically most of the enterprises today use Docker containers to actually deploy your microservices to the cloud. Now, when you are learning Docker, what are the things that you would want to focus on? What are the things that you would want to learn, right? One of the things that you need to understand is how to build an image, right? From your code, you build an image and you push it out to a Docker repository. So that's what you would do when we are, actually it's not a Docker repository, I should call it Docker registry. So this is what is done when we actually do anything with Docker. So from your code you build an image and you push the image out to Docker registry, and from the Docker registry you can pick the image and deploy it to any place you would want. You can deploy it to your own data center, you can deploy it to the cloud, you can deploy it to anywhere you would want from your Docker registry. So this Docker registry, you can kind of think of it like a Maven repository. So Docker registry is a place where all the images, Docker images, are present. So you need to understand the concepts of image, a registry. You need to understand the concept of a container. So a static version is an image. When something is running on a Docker engine, it's called a container. You need to understand the Docker architecture that we talked about earlier. You need to understand how to build images for different kinds of applications. If you are in the Java world, you might want to build an image with a jar, you might want to build an image with a var file, you might want to build an image for a full stack application. You can try and build images for microservices and try and deploy them. So that's one of the ways you can actually play around with Docker. And also you need to try and build a number of Docker images. There are a number of plugins which are available. One is called Dockerfile Spotify plugin. The other one is called Jib. Jib actually is one of the wonderful plugins which is provided by Google. There is also Fabric 8 Docker Maven plugin. So all these plugins are useful in building Docker images for Java projects. The other interesting thing that you definitely need to learn is something called a Dockerfile. So Dockerfile can contain instructions on how you can actually build a Docker image. The other interesting thing that you can learn whenever you are trying to learn Docker is how to use existing Docker images. So let's say I would want to run a MySQL database. Let's say I would want to run RabbitMQ. One of the things that you can do is you can go to Docker Hub. Docker Hub is the central Docker repository. So you can go to Docker Hub and you can get the image of these. So you can get the images for MySQL, you can get the images for RabbitMQ and try and run them in the local as a Docker image. You don't really need to install it on your local machine. You just use Docker, pull the image, run it, use it. Once the application is done and dusted, you can throw them away. So that's what Docker really enables. Now, so let's look at some of the best practices around Docker. One of the things that you would want to learn around Docker is all the commands, right? So you'd want to be an expert with Docker, you want to play with all the commands. You'd want to understand that images, the Docker images which are built are actually built in layers. So you'd want to understand how image layering works and how you can actually efficiently cache layers. So you can minimize the size of the images by properly caching the layers. You can also learn how to do multi-stage builds. Multi-stage builds is an awesome way actually to build your applications, actually build your Docker images. And the other interesting thing is to learn Docker Compose. So if you are running something in your local machine and you want to bring up 5 or 6 containers, then you can use Docker Compose. So you can configure everything in Docker Compose, and with one command you can actually bring up 3 or 4 different applications using Docker Compose. So in this last few minutes we looked at Docker and we looked at how you can learn Docker. What are the important things you would need to know? What are the important things you need to try? So to summarize, you need to understand Docker architecture, you need to understand the basic concepts of Docker, you need to build Docker images for a number of applications, and you'd want to play around with all the plugins which are present, and you'd want to play around with Dockerfile to build Docker images. So those are some of the interesting things that you might want to learn about Docker. Now let's look at AWS Fargate and AWS ECS Nav. Let's look at what is involved in running this. Before we get to AWS ECS and AWS Fargate, let's try and understand what is container orchestration. Why do we need AWS ECS and AWS Fargate? Now, one of the important things is when we talk about microservices architecture, we have maybe hundreds of microservices, and you would have thousands of instances of these microservices. And what you would want to make sure is these microservices are all always available. How do you ensure that? The way you can ensure that is by having something to manage it, and that something is what is called a container orchestration tool. What you can give the container orchestration tool, for example, is I'll say this is the container image and this is the configuration. So the inputs to a container orchestration tool typically, so container orchestration tool takes these two things as an input, and what the container orchestration tool does is it manages a cluster of servers. So once I say this is the image, this is the configuration, I would want this many instances, the container orchestration tool will make sure that that many instances are available on the cluster, that many instances of the microservices are available inside the cluster. And ECS Fargate is one of the popular, actually AWS ECS and AWS Fargate are a couple of popular container orchestration options. Now you might be wondering what is the difference between AWS ECS and AWS Fargate. Let's look at it right now. When we talk about AWS, the virtual servers are called EC2, Elastic Compute Cloud. When we use ECS, when we use AWS ECS, you are responsible for managing the cluster. So you are responsible for adding EC2 instances to the cluster. So you need to manually go, or you need to set configuration to ensure that you keep adding the right number of EC2 instances when you are playing with ECS. So when you are playing with ECS, you are responsible for your container images, you are responsible for your configuration, and you are responsible for managing the EC2 instances which are present in the cluster. However, when we talk about Fargate, you don't really need to worry about managing the cluster. Fargate would take care of managing the cluster. All that you need to tell AWS Fargate to do is, this is the container, this is the configuration I would want. I would want 5 instances of this, I would want 10 instances of this, 15 instances of this, and AWS would automatically take care, AWS Fargate would automatically take care of provisioning the infrastructure and taking care of everything inside your cluster. So AWS Fargate is also called serverless for containers, because you just give it a container and you don't really worry about what's in the server. So that's why it's called serverless for containers as well. One of the interesting things that you need to remember, this is a cloud specific option, right? You are using AWS ECS or AWS Fargate, these are only supported on AWS. That means you are tied to AWS. Now, if you want to learn ECS or Fargate, what are the important things that you would want to learn? The fundamentals of defining a container and a container configuration is by using something called task definition. So you need to create something called task definition, you need to create something called task, you need to create the cluster, you need to create something called a service to expose your task to the outside world. So these are some of the fundamentals of AWS ECS Fargate you need to understand in depth. The other thing you need to understand is the networking concepts which are present inside AWS. You need to understand things like virtual private cloud, VPC. You need to understand something called subnet, and you need to understand how to create security groups and manage them. The other things that you would want to understand whenever you would want to use a container orchestration service, the reason why you go to a container orchestration service is because you have microservices. So whenever we go to microservices, we would want to play with them, we would want all the infrastructure features around them. So for microservices, you would want to use service discovery. So for service discovery, typically in AWS, you can actually use DNS, AWS DNS, and you can use something called hosted zones. The other things that you would want to understand is how autoscaling and load balancing works. So you can create something called elastic load balancers, and you can create target groups to load balance. And the other interesting thing is centralized configuration. So centralized configuration is something which is very important for microservices, and in the AWS world you can use something called a parameter store. So you can use parameter store to manage the centralized configuration. The other thing you would want to learn is monitoring. Monitoring in the cloud, like in AWS, is typically done using CloudWatch. You might also want to learn how to do distributed tracing. In AWS, the service to do that is X-Ray. You might also want to play with CI/CD, continuous integration, continuous delivery, similar to Elastic Beanstalk. The CI/CD in here is also implemented using code pipeline and code build. So code pipeline / code build are typically the things which are used to implement CI/CD. The last thing you might want to play with is something called a service mesh. So a service mesh is like AOP, aspect oriented programming. You can actually change stuff across microservices by like doing things with a service mesh. It actually adds something called a sidecar to each of the microservices and helps you to do things with microservices. One of the interesting things that you can do with a service mesh is something called a canary deployment. The service mesh implementation inside AWS is actually called AWS App Mesh. So these are some of the important things that you might want to play with whenever we talk about AWS Fargate and AWS ECS. The important thing to remember always is that this is a cloud specific thing, right? So this is something specific to AWS, and that's the reason why a lot of people actually go for Kubernetes, which is kind of a cloud neutral solution. Now it's time for Kubernetes. Why do we need Kubernetes? As we talked until now, when we go for microservices architecture, we'll have multiple microservices which are talking to each other. So you have these microservices talking to each other. Let's call this A, let's call this B, C, D, E, and F. There might be 10 instances of A, 5 instances of B, 15 instances of 17 instances of D, and so on and so forth, right? So one of the interesting things about having multiple microservices, actually in real world, there are enterprises with thousands of microservices, and each microservice you might be having thousands of instances running. So when you have these kind of infrastructure, and you would have typical requirements around like these like applications would be that you'd want high availability. You'd want the application to be always available. You'd want self-healing. Let's say there are 5 instances of an application running, one of the instances goes down, you'd want the other instance to come up immediately. You'd want zero downtime deployments. So whenever I want to deploy a new version, I would want to be able to deploy it with zero downtime. So these are some of the important requirements whenever we talk about microservices architecture. The other important requirements when we talk about microservices architecture are typically you want service discovery, you'd want load balancing, all these kind of interesting stuff, right? One of the options that you have is you can go for some of the provisions which are provided by either Spring Cloud, or you can actually go for some of the provisions which are provided by the cloud providers, but it makes things really complex, because then like if you are using cloud provider specific feature, then you are tied to the cloud provider. If you are using Spring Cloud specific feature, then it will be difficult to use them from a Java, like from a different language other than Java. From Java applications, from Spring Boot applications, you should be able to easily connect to Spring Cloud things. But let's say you have a Python application, a Node.js application, or you'd want to build a new kind of application. From there, connecting to this specific thing, to the Spring Cloud specific thing becomes very tough. And that's where this thing called Kubernetes comes into picture. Kubernetes is a container orchestration solution. So Kubernetes is cloud neutral container orchestration solution. Like there are cloud specific container orchestration solutions, like for example AWS has this AWS Fargate or AWS ECS. That's a cloud specific container orchestration. Kubernetes is a cloud neutral container orchestration platform. The amazing thing about Kubernetes is that it's declarative. What do you mean by declarative? All that you need to tell is this is the container image I would want to run, and I would want 5 instances of it running. That's it. That's what you need to tell Kubernetes, and Kubernetes would make sure that there are 5 instances of that application running all the time. Even if one of these instances goes down, it would bring another one. So Kubernetes is very powerful in that sense. Now let's see how Kubernetes architecture looks like. So you have a container image and you have some configuration that you need to provide. So 5 instances, these are the databases I would want to connect to and things like that, all that configuration. And this is the input for Kubernetes, and Kubernetes would actually use a cluster. In this cluster, we would have things called master nodes and you have nodes. This is at a high level the architecture of Kubernetes. So you can say I would want this container image, this many instances, and provide the configuration out to Kubernetes, and Kubernetes would actually deploy that down to a cluster. In the cluster, you can actually have a number of master nodes. Typically, you would want to have multiple master nodes because you would want high availability. The nodes are where the actual containers are finally running. So this is where the actual work is done. The master node is for managing the work on the nodes. So when you would actually say container, I would want 5 instances of this container running, then master node would be checking, okay, are there 5 instances running? If there are less than 5 instances running, it would actually add a new instance. It will also make sure that it's highly available. If any of the instances goes down, it brings it up, it provides self-healing, all that. Like master node is for managing the cluster and nodes are the ones which does the work. So this is at a high level the architecture of Kubernetes, and we already looked at the important features down here. The most important thing about Kubernetes is that it's cloud neutral. There are services offered by all the cloud providers for Kubernetes. Google Kubernetes Engine, you have Azure AKS, Azure Kubernetes Service. We also have AWS EKS, Elastic Container Service for Kubernetes. So all these are the services which are present for Kubernetes. You can run Kubernetes on your local machine. You can actually run Kubernetes inside your data center. You can also run it on the cloud. You can run it you can also use OpenShift. OpenShift is another Kubernetes based platform. So Kubernetes is present almost everywhere there is cloud. Now, if you want to learn Kubernetes, what are the things that are important? Architecture we already talked about. You need to understand a few important concepts around Kubernetes. What are the concepts that you would want to understand around Kubernetes? You need to understand what is a pod. You would want to understand what is a service. You would want to understand what is an ingress. You would want to understand what is a replica set, and you would want to understand what is a deployment. These are some of the very, very important concepts which are present in Kubernetes. You'd want to be able to use kubectl. Kubectl is the command line which is provided by Kubernetes. It's very, very important. If you'd want to be really, really good at Kubernetes, you have to be an expert at kubectl. The other thing you might want to learn is persistent storage. If you want to store data, persist something across containers, you want to share something between containers, then you need to go for persistent storage. So there are things like PV, persistent volume, PVC, persistent volume claims, which help you to do persistent storage in Kubernetes. The other things you would want to learn is how to do application configuration. So you can store application configuration in Kubernetes by using something called config maps, and you can also store secrets also in Kubernetes. So secrets is to store something like a database password or things like that. And the greatest way of learning Kubernetes is to actually deploy a variety of applications. Deploy a web application, a full stack application, a microservice. So deploy a number of applications and try playing with Kubernetes. The amazing thing about Kubernetes is the concept of service mesh. So with service mesh, one of the popular service meshes is Istio. With Istio, you can actually get multiple features out of Kubernetes. You can do things like canary deployments. You can add observability. So you want to see what's happening inside your cluster, inside everything that's happening in Kubernetes. So you can add observability using Kiali. You can actually add a lot of metrics and visualization. So you can generate a lot of metrics and visualization around your cluster by using Grafana and Prometheus. So Grafana, Prometheus is a time series database. So you can actually do all that stuff. The other interesting thing is distributed tracing. So you can do distributed tracing using Jaeger. Jaeger is one of the popular distributed tracing options. You can actually integrate Istio with all this stuff and do a lot of amazing things. The last and most important thing that you'd want to learn about Kubernetes is something called Helm. Helm is the package manager for Kubernetes, if I can call it that way. It simplifies the configuration. like whenever you talk about Kubernetes, there are a lot of YAML files that you would use. So all these things can be configured using YAML files, and if the YAML files become big, they become really tough to manage, and you can actually use Helm to simplify the creation of the YAML files and store your configuration in a very easy way. So there you go. Those are some of the important things that you would want to learn about Kubernetes. Kubernetes is an amazing thing. I mean, I love Kubernetes and the flexibility it brings, especially the fact that it's cloud neutral. Google Kubernetes Engine, Azure AKS, AWS EKS, all these support Kubernetes. And once you, like, Kubernetes is something which is a little difficult to start with, but once you get hang of it, it's like amazing. So I would recommend you to actually try out Kubernetes and see what you can learn about it. Now that we looked at all the recommended skills and the details of each of the skills, let's look at the entire learning path. What is the recommended course path and what is the recommended video path that you would want to take? You'll find a link. You would find the link to this particular page on in the description of this particular video. You can go down there and select that particular link, and you can come down here. As we discussed earlier, the prerequisites for this is learning path 01 or 02. You would need to have the skills to build a web application. You would want to have the skills to build a REST API. You would want to have the skills to build a full stack application, and also like you'd want the skills to build microservices. So the recommended course path actually starts with microservices, where you would start with building a REST API, and you would also build an amazing microservice using all the Spring Cloud features. So you'll use all the features around service registry, load distribution. You'll use Eureka, Zool. You'll use Ribbon. You'll use Faincline. You'll use Zool to do API gateway stuff. You'll use Zipkin to do distributed tracing. So that's what this course enables you to do: learn microservices, learn Spring Cloud, and become good at it. The next course that we would recommend is learn Docker. Docker is very important because you would want to containerize your microservices, your applications. This Docker course teaches you the fundamentals of Docker, and it also containerizes a number of Spring Boot applications. It containerizes a REST API, full stack application, microservices, and you will also learn about Docker Compose. After that, we would recommend you to actually go into AWS and actually look at the AWS Elastic Beanstalk. This is a platform as a service offering from AWS. So this would be the easiest way to get started with AWS. All the other services provided by AWS are a little bit more complex. I think AWS Elastic Beanstalk is the best option. You can deploy a number of applications down here: a jar file, a var file, a web application, a full stack application, and all that stuff. The next step is to actually do container orchestration. The container orchestration tool which is provided by AWS is AWS Fargate. AWS ECS also is an interesting option. So you can learn container orchestration with AWS Fargate and AWS ECS. This course digs deep into microservices and also looks at all the typical features which are needed with microservices. So all the stuff that we talked about earlier that you would want with a microservice, all of them, we implement them on AWS using AWS Fargate. The next course which we recommend is actually Kubernetes Crash Course for Java Developers on Google Cloud. This course right now is on Google Cloud, but one of the options we are exploring is actually to add deployment into AWS as well. So we are looking at options to deploy, use Kubernetes, and also create Kubernetes clusters on AWS EKS, which is Elastic Container Service for Kubernetes. But for now, this course is also amazing for you to learn Kubernetes, as well as it gives you an introduction to Google Cloud. So it's an amazing course for you to get started with Google Cloud as well. So in this learning path, we looked at all the stuff around AWS. We looked at the importance of learning microservices, Docker. We looked at the importance of learning the platform as a service offerings of AWS, including Elastic Beanstalk, AWS Fargate, and we looked at the need to learn Kubernetes. We also have a few recommended preview courses which are present in here. You might want to check them out. These are quick videos to get started with those tools. If you want to look at other learning paths which we are offering, you can click down here and you can look at the other learning paths on full stack, microservices, and other cloud platforms. I hope you are having an interesting time watching this video. Becoming a cloud expert is very, very important in these times. I think cloud is something which is here to stay, and AWS is the most popular cloud among all. So this is a very interesting career path for you to choose. I'm sure you would make the right choice, and I'll see you in another video. Until then, bye-bye. I'm sure you had a wonderful time watching this video. A number of times I am asked this question: where do I go from here? What next? There are 4 amazing things that you can do to benefit from the great content that we are creating at in 28 minutes. A number of developers wonder how they can become a full stack developer, a cloud developer, a microservices developer, or a DevOps developer. We have amazing learning path videos to help you understand all these career paths and decide what you want to be. Number 2, this video is part of a series of video called Draw with Ranga, and you can actually download the free PDF containing all the amazing images which we have drawn during these series of videos by registering for a free course. Number 3, you can check out our 500 plus amazing videos that we have created over a period of last few years. These videos are organized into playlists to help you learn Spring, Spring Boot, full stack, microservices, and the cloud. Last but not the least is number 4, check out our course catalog. We have a wide range of courses to help you become an amazing developer. So what's stopping you? Go ahead and keep learning in 28 minutes. If you like this video, make sure that you like and also subscribe to this channel. Until I see you in another in 28 minutes video, here's bye from Ranga at in 28 minutes.